Mathematics at Init College, a YouTube channel for high school mathematics education. Mathematics 2C, Swedish high school education system. Hi, this is Babak. In this video I'm going to solve the following problem for you. This is a problem on the topic of systems of linear equations. Let me read the problem for you first. Solve the following system of linear equations. The first equation is 5 times the square root of 5 times x minus 7 square root of 3 times y equals to 29. The second equation is x over square root of 5 minus y over square root of 3 equals to 1. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do it correctly, the answer that you will get for x is equal to 2 times the square root of 5, and the answer that you will get for y is y equals to square root of 3. Okay, now let us start solving the problem. So if you look at these equations, you see that in this equation there are fractions. So it is usually better to get rid of fractions immediately by multiplying both sides of this equation by an appropriate number. Here the appropriate number, hopefully you can realize, that is the square root of 5 times the square root of 3. Because if I multiply this equation by such a number, when I multiply this number on the first term, square root of 5 and a square root of 5 will be cancelled, and then I will have a square root of 3 which will be multiplied in the numerator, and that's okay. But then when I multiply that number by this, then a square root of 3 and a square root of 3 are cancelled, and then a square root of 5 will be multiplied in the numerator. That would also be okay. So, and the right hand side will be multiplied by this number. But what is the other name for this number is just a square root of 15. Okay, so let me just do that. So what I do, in principle, I am multiplying both sides of this equation by this number. Okay. I think it would be better to write it here first, so let me just do that. So I have my equation x over square root of 5, yes, and then I have minus y over square root of 3 is equal to 5. So what I am doing, I will multiply both sides of my equation by square root of 5 times the square root of 3, yes. So what do I have here? I have this one minus this equals to 1. So I am multiplying both sides by that. Of course, this is not a very proper way of writing. I have to write this and then write another one for this one, but you understand what's going on now. Now I multiply this here inside, this and that are cancelled. This will multiply itself into the numerator as I explained before. So it becomes square root of 3x. The second one, this one will be cancelled with that one, and then this will be multiplied here. I have also a negative sign to take care of, so it becomes this. On the right hand side, I am multiplying 1 by this number, but a better name for this number, as I mentioned again earlier, is square root of 15. Okay, now instead of considering this system, I can consider a system which probably is a little bit easier to work with because I do not have any fractions involved in that system. Okay, so I'm just copy and pasting the first equation instead of the second equation. I would write this that I got after multiplying both sides by this factor. Okay, now I start thinking how to solve the problem. So let us use method of addition, okay? So for example, I want to get rid of one of these variables. So what can I do? For example, let us consider getting rid of y variable first. Of course, it doesn't matter that much, but we can decide about getting rid of that. So I want to make these coefficients to be the same number with opposite sides. Okay, because both of them are negative, so it is clear that I should multiply one of them with a negative number to make it positive, and the other one with the positive number to keep it negative, so that when I add them they can cancel. But of course these numbers are far away from being cancelled right now, so I need to adjust the numbers. Okay, so what we can do, I can multiply, for example, the first one by, I can multiply the first one by 7 square root of by square root of 5, and I will multiply the second one by minus 7 square root of 3. Yes, hopefully you are able to guess yourself. Let me see why this is working, because now let me just write the new system. If I multiply square root of 5 by the first number, what will happen? It becomes 5 square root of 5 multiplied by another square root of 5. But this becomes a square root of 25, which is 5, and this 5 multiplied by this 5 becomes 25. So if I multiply this by that, it becomes 25. So it becomes 25x minus, I multiply this one by that one. So square root of 5 times square root of 3 is a square root of 15. So I will have minus square root of 15y. On the right hand side, I will have 29 square root of 5. Okay? And now let us go here. I multiply this number by this number. Minus 7 square root of 3 times the square root of 3. This becomes a square root of 9, which is 3, but 3 times minus 7, it is minus 21. The first thing is that this minus sign will be, with this minus sign, now becomes a positive number. But then what will happen? I have positive, and then I have 7, then I have a square root of 3 times the square root of 5 becomes a square root of 15 as desired. So hopefully now you realize why I have chosen those numbers. But you need to be careful about the right hand side. Okay, so let me do the right hand side here. So you will multiply minus square root of minus 7 square root of 3 by square root of 15. Okay, so what can you do? You can write it as minus 7. If you multiply the ones under the square root sign, it becomes 45. But it's always good to simplify this as much as possible, even though square root of 45 is not a 45 is not a complete square, but you can still make a little bit things simpler. So for example, 45 can be written as 9 times 5. But then this becomes minus 7 square root of 9 times the square root of 5. But the square root of 9 is 3, and then I have a square root of 5. So this number becomes minus 21 square root of 5. So that is important to understand. Okay, so when I multiply this by that number, instead of writing minus 7 square root of 45, I can write it minus 21 square root of 5. Yes, so it becomes minus 21, let me change my color, minus 21 square root of 5. And now I use the method of addition and I add them. When I add them, of course, intentionally I fine-tune these coefficients to be cancelled, and then this one and that one, 25x minus 21x, is just simply 4x. And on the right hand side, what I have 29 square root of 5, and I have minus 21 square root of 5. So if I add them, I have 29 of these numbers, 21 of them are gone, so what is left for me is 4 of them. It remains 8 of them. 29 of them minus 21 of them is 8 of them. Yes, so 8 square roots of 5. And then what I want to find x, so I divide both sides by 4. Then 8 and 4 are simplified, so I will get x equals to 2 times the square root of 5. Yes, so that's exactly the answer I'm supposed to find. So what I have done, I have divided by 4, it becomes 1 times. Yes, and I have divided this by 4, it becomes 2 times. So that's x equals to 2 square root of 5. So I can take this one put it in this equation or in this equation or this simplified version, it doesn't matter. But I think here it's easier, yes? Let us just use this one. Okay, so what I do, instead of x, I put 2 square roots of 5, which is got right now, divided by square root of 5, and then minus y over square root of 3 is equal to 1. So the reason that I chose this one, because now you see this one and that one are cancelled, so what is left from this is just 2 minus y over square root of 3 is equal to 1. Then I move 2. I will move this 2 to the right. It becomes negative 2. 1 negative 2 is negative 1. But then I want to find y, so I have to multiply both sides by negative square root of 3. If I do that, the left hand side becomes just simply y. The right hand side minus the square root of 3 times minus 1 becomes the square root of 3. So that would be the answer to y. But of course it doesn't matter which equation you use. I thought that this would be simpler if I want to use it, but you can use that number you found for x here or even in this equation. It doesn't matter. Okay, so I hope that this video was useful for you. You will find the link to the PDF file of the solution below this video. Until the next video, be safe and goodbye.